Section 3.3, Linear Equations and Their Graphs. A linear equation there shouldn't be a comma there, in x and y is an equation that can be written in the general form ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. One or the other can be 0, but not both. Here are some examples of linear equations in general form. So that's our general form, ax plus by equals c. So whatever number is multiplied times x is our a value. Whatever value is multiplied times y is our b value, and c will be the number by itself. So in 5x plus 3y equals 10, a is 5, b is 3, and c is 10. Our next equation is x minus 2y equals 6. So a, there is no number multiplied times x, but it's always understood to be 1. A is 1, b is negative 2, and c is 6. Our next equation, x equals negative 4. The numerical coefficient, the number that's multiplied times x, is 1. There is no y, so its numerical coefficient is 0. There is no y, so it must have been multiplied by 0. And finally, c is negative 4. How about y equals negative 4? There is no x, so x is 0, or a is 0. Y must have a numerical coefficient of 1. And once again, negative 4 is over there by itself. A solution of an equation in two variables is an ordered pair of numbers. An ordered pair, remember, first you have the x, then you have the y. An ordered pair of numbers that when substituted for the variables make the equation true. For the equation y equals 3x minus 1, find 5 solutions by completing the following table. So our table specifies first that x equals 1. If x equals 1, what is y? So we're going to substitute 1 into our equation. Our equation again is y equals 3x minus 1. So we'll have y equals 3 times 1 minus 1. That's 3 minus 1, that's 2. So when x is 1, y is 2. What about when x is 2? If x is 2, y is 3 times 2 minus 1. It must be 5. What about when x is 0? Y is 3 times 0 minus 1. That's a negative 1. Now we have some specified y values. Our first y value is 0. When y is 0, what is x? So we have 0 equals 3x minus 1. Add 1 to both sides. 1 equals 3x. Divide both sides by 3. And x is 1/3. Finally, we have y is 5. So if y is 5, we have 5 equals 3x minus 1. Can you tell me what x is? If we add 1 to both sides, we get 6 equals 3x. Divide by 3, you get x equals 2. The graph of a linear equation in two variables consists of all points whose coordinates satisfy the equation. We are going to learn to graph a linear equation in two variables in three different ways. The first way that we are going to learn to graph will be to choose three x values. We will put them in the table. Our table will be in the shape of a T, so it's called a T-chart sometimes. So we will choose three different values to put in the table. I usually choose the numbers 0, 1, and 2. You can choose 0, 2, and 4. Sometimes you want to be careful what numbers you choose, but sometimes it doesn't matter. This equation of y equals negative 2x plus 3 is not really a tricky equation, so 0, 1, and 2, or pretty much any number you want to choose, will be fine as long as it fits on the chart. As long as we're able to graph it within these values. Looks like we have x negative 5 to 5, y negative 5 to 5. So unless we're willing to change the scale, we want to stay within those values. So once we choose our three values and put them in the table, we complete the table by calculating the corresponding y values. So when x equals 0, y equals negative 2 times 0 plus 3. It's 3. When x equals 1, y equals negative 2 times 1 plus 3. It's 1. When x equals 2, y is negative 2 times 2 plus 3. Negative 4 plus 3, negative 1. So that gives us 3 points. It really only takes 2 points to determine a line. Once we put our point here at 0, 3 and our point at 1, 1, there's only one line that we can draw through those 2 points. So the third point, 2, negative 1, is our checkpoint. We plot all 3 points, and then we look at them and determine whether or not they line up. They do. So now we want to draw as straight a line as possible through our 3 points. We plotted the points, we drew the line. Now let's choose 2 points that we plotted and find the slope. So the first 2 points I'm going to choose are these two. The slope of this line must be negative because this line is going downhill left to right. It is decreasing. We can calculate the rise of 2, the run of 1. You could think of it as negative 2 and positive 1 if you want to. That will give us a slope of negative 2 over 1, negative 2. M equals negative 2. Just for fun, let's do it again. Only this time, let's use this point and this one. So if we think about the rise, or in this case, the fall, negative 4, the run of 2, once again, we calculate the slope, rise over run, negative 4 over 2. Look at that, that simplifies into negative 2. It doesn't matter which 2 points you choose to use to calculate the slope. You still will get negative 2. We want to compare that slope of negative 2 with the equation, which once again is y equals negative 2x plus 3. Do you notice anything? The slope is negative 2, and there's a negative 2 multiplied times x. Is that always true, or is that just a coincidence for this one problem? It is always true. our equation in this particular form, when it has been solved for y equals, if there is a number multiplied times x, that number is the slope. At what point does the line cross the y-axis? It crosses the y-axis right there at the point 0, 3. Compare the point 0, 3 to the equation. There's a 3 here, there's a 3 here. Is that a coincidence? No, there's not a coincidence involved here. When the equation has been solved for y equals mx plus something, that something will always be the value of the y-intercept, of where the line crosses the y-axis. It is the y value. X is 0 if a point is on the y-axis. X is 0 and y will be whatever that number is at the end by itself.